Hello, this is section 2 of the Jupyter in-depth video series. This section will focus on the Jupyter configuration files and options. Rather than explaining each option, the focus will be on the program internals, locating appropriate references, using the tools from section 1, and possible business use cases for configuration data. It will start off by covering how to extract all of the configuration options from each of the Jupyter configuration files for easy reference. After that, the Python ConfigParser module will be compared to the Traitlets config class in the Jupyter application package. Storing configurations in pandas, JSON, and SQLite will be covered, as well as overriding configure options from the command line. At the end of this section, automatic logging of configuration changes to private SQLite store and regex-based file system monitoring via Watchdog will be demonstrated. Section 2.1. To start things off, we will generate the configuration files and extract the default options and parameters from them. Extracting the default values will give us an idea of what Jupyter is doing under the hood when we start the application before we are familiar with the code and internals. The Notebook console and Qt console have separate configurations. After generating the files, we'll take a look at how we can interact with them. If no configuration file is specified, Jupyter will use the default values when serving notebooks or consoles. The files are documented beautifully, and a line magic can be implemented to make it easily searchable from the notebook cells on the off chance you have not configured Vim or Emacs as a drop-in editor. Storing configurations in a database is a very likely business use case to become familiar with. Inspect the migrate.py module from Jupyter Core and identify the line of code that creates a config instance. For each generated configuration file, the code in the pull configurations function strips the available options and groups them in dictionary format. From that collection type, data will easily convert to JSON, data frame, or other popular formats. It is not mandatory to write these files out in the Python ConfigParser file format, and the next step is done as an exercise so that we can become familiar with the contents of the files while comparing the operations of the ConfigParser module from the standard library to the config class in the Traitlets package. In fact, they should not be written in the configurations directory because the configuration loader will load all files that end in py or JSON from the configuration directories at startup. There is a custom error message for values not understood during configuration load. Preference is given to JSON files during load. This exercise is practice for additional configuration files that we may encounter and want to store in our configurations database. Logging and configuration management are essential in areas where we perform research. The write ini configs function simply writes the key value pairs to an ini style configuration file. Each section is labeled the way that the ConfigParser module expects to see them. For each file, we can create a parser instance. The parser instance has built-in methods to help retrieve values from the data and behave similar to a dictionary. The parseQuickConfig function simply writes the data to an unformatted key equals value store which Traitlets load config is able to recognize. While the configuration parser instance makes the values and sections easily searchable, it has dropped the case and all of the values are now interpreted as strings. This will cause the Jupyter application to produce a configuration error if passed into load config method because the values are not typed correctly, and the case system denotes a hierarchy within the Traitlets configuration. For our purposes, it will be more useful to log the files to JSON format, however many commercial applications use the above file format. Underneath the hood and in between the widgets in the kernel lies the Traitlets package. Application and PyFileReader are in use in the Jupyter Core application module. The Jupyter app inherits from application and can call the loadConfig file method on itself when instantiated. After loadConfig is called, as in the quick-to-config method, the resultant configuration object is a dictionary of key value items passed from the file. At this point, any additional command line options are passed in and override values from the files found in configuration directories or in the default configuration. From this format, it will be easier to go to Pandas data frame or perhaps to log to a production database such as Mongo. Working with JSON configurations is essentially the same as Python configuration file loading with Traitlets. Once the data is in a config object, it can be passed to the multi-kernel manager and kernels started from there will inherit the configuration data. As an exercise, investigate the login configurable class from traits.config.configurable, which is in use in the multi-kernel manager.py module of the Jupyter client package.